This lesson is for Mrs. Cucci's College Now Pre-Calculus class. We are on lesson 6.4b, composition of trig functions and their inverses. So if you want to go ahead and get your notebook open and pen or pencil ready to go, we'll get started. Okay, so when we're talking about composition of trig functions and their inverses, what we're able to do is we're able to look at this in comparison to our functions to kind of get an idea of how these are going to work. So, for example, if I have f of f inverse of x, this would simply equal x. So what I wind up seeing is when we take these compositions of our trigonometric functions, this actually applies the same way. So, and you're going to want to write these down. If I have sine of sine inverse of x, this is going to equal x. Okay, and the same thing is going to go for cosine of cosine inverse of x. That's also going to equal x, as well as tangent of tangent inverse of x. Okay, and that's for all x in the domain of the specific trig function. Okay, so what we're going to do is we're going to work through on how we find these inverses. Composition of inverses. So let's look at our first example, and this is a continuation from last lesson, so we are going to be on example 3 to start. And our first example is going to be cosine of cosine inverse of the square root of 3 over 2. So again, it becomes very important that you guys know your unit circle or first quadrant facts. Because you need to be able to look at cosine inverse of square root of 3 over 2 and know when cosine is equal to square root of 3 over 2. Okay? So, since square root of 3 over 2 is in between negative 1 and 1, we're going to be able to pull from that to figure out what we're going to be using. Okay? So, when is cosine square root of 3 over 2? Well, cosine is square root of 3 over 2 at 30 degrees. Okay. And when is cosine 30 degrees? Well, or what is cosine at 30 degrees? It's square root of 3 over 2. So it's simply taking it and doing it piece by piece. You do what's inside the parentheses to start and then work from there. Okay. Okay, so the next one we're going to do is sine of sine inverse 1.8. Okay, so the first thing that we're looking at is sine inverse of 1.8. So when does sine equal 1.8? Okay, and since we know that the range for sine is between 1 and negative 1, we know that sine doesn't actually exist at 1.8. So for this, there is no solution. Or, in other words, we can say that it does not exist. Okay? Alright, so we do have some special cases that we need to be aware of. So that first special case is sine inverse of sine of x. Now notice this is in opposite direction. That's also going to be equal to x. And that's for all x in the range of sine inverse. Cosine inverse of cosine of x, again, is going to be equal to x. And tangent inverse of tangent of x is also going to be equal to x. So those are just some special cases. Notice they're very, very, very similar to what we just looked at. It's just written differently. Okay, so let's look at an example based on that. Example 4. And let's take a look at tangent inverse of tangent pi over 6. Okay. All right, so since pi over 6 is in negative pi over 2 to pi over 2, the range of the tangent inverse function, we can use tangent inverse of tangent x equals x. Okay, so since it's in that range, we can utilize the composition. Okay, so this becomes very simple, and we can say, since it's in that range, it's just going to equal pi over 6. Okay. So this goes back to when we talked about what portion of that unit circle our range existed on. And since pi over 6 is in that range, we're just going to take that value. Okay, this was what tangent was. All right, so let's look at another one. Sine inverse of sine at 3 pi over 4. Okay, so 3 pi over 4 is not in the range. Okay, so we have to look at this one a little bit differently. The range for sine was from negative 2 pi to 2 pi. So from here again. So since 3 pi over 4 is not within this range, it's over in the second quadrant, we have to do this a little bit differently. Okay, so the first thing we need to know is what sine at 3 pi over 4 is. Okay, so sine at 3 pi over 4, if I notice this 3 pi over 4, we need to know its reference angle. And that should be pretty simple. Anytime you see a 4 in the denominator, you have to think pi over 4, or 45 degrees. Okay, so sine at 3 pi over 4 is going to be radical 2 over 2. And since we're in the second quadrant, it's going to be positive. So now, sine inverse of radical 2 over 2, I need to know when sine is equal to radical 2 over 2. And I want to stay within my given range from negative pi over 2 to pi over 2. That's going to be at pi over 4. Okay, so our next example is example 4. Example 5. And we're going to simplify each of the following. So we've got sine of tangent inverse of negative 1. So again, we always start moving from right to left. Okay? So tangent inverse of negative 1 is the number or the angle theta. And remember, we're going from negative pi over 2 to pi over 2, whose tangent's equal to negative 1. So what we can say is tangent theta equals negative 1, right? That's another way to look at it. And I'm looking for the angle theta. So we know tangent is equal to negative 1 at pi over 4, or it's equal to positive 1 at pi over 4. But since I want it to be on this interval, and I don't want it in that first quadrant because it's positive there, I want it here in the fourth quadrant. So what I can say is that it's going to be negative pi over 4. Okay, we're rotating clockwise instead of counterclockwise. Okay, so now this brings me to sine of negative pi over 4. And I know that sine of pi over 4 in the first quadrant is radical 2 over 2. But since I want it negative pi over 4, which again is in that fourth quadrant, it's going to become negative radical 2 over 2, because sine is negative in the fourth quadrant. Okay, my next example, cosine inverse of sine of pi over 2. Okay. Okay, so the first thing we're looking for, again, we're moving from right to left, as we're looking for sine of pi over 2. Now, pi over 2 is 90 degrees, so that's going to be, sine at pi over 2 is going to be 1. Okay. Now, cosine inverse of 1, so what I'm saying is cosine theta equals 1. When does cosine equal 1? And we actually see that occur if we're talking on the specific interval that we want to be on. We see that occur at 0 degrees, or 0 radians, same thing. Okay? All right. Let's try another example. This time we're going to do sine of cotangent inverse of x over 2. Okay, so since cotangent is defined on 0 to pi, okay, cotangent is defined on 0 to pi, we have to consider quadrants 1 and 2. Okay, so what we can do from here is we can draw right triangles based off of this information, always from the origin. Okay, and of course this angle in here becomes theta. And cotangent is adjacent over opposite. So this becomes my x, this becomes my 2. Okay, so if I want to know, to go further to figure this out, we kind of have to take it step by step, right? So we need to go ahead and find the hypotenuse here. And we do that using Pythagorean theorem. X squared plus 2 squared equals c squared. Okay, so we get the square root of x squared plus 4. All right. Remember, x here is going to be negative and x here is going to be positive because of the direction you've moved. Okay, so since we have this information, what we can do now is we can find sine based off of this. Remember, sine is opposite over hypotenuse. Okay, so what we were able to do is, because we can rewrite this as cotangent theta equals x over 2, that's why we were able to create the triangle from that. Okay, now we find sine of that. So sine of that angle theta is equal to opposite over hypotenuse, so 2 over the square root of x squared plus 4. So essentially what we can say is sine of cotangent inverse of x over 2 is equal to 2 divided by square root of x squared plus 4. Okay, we've got one more example to look at. Okay, so we're going to evaluate sine of sine inverse of a half plus cosine inverse of 5/13. Okay, so this one's obviously a little bit bigger and longer. All right, since sine inverse of a half and cosine inverse of 5/13 are both angles, the expression is the sine of the sum of two angles. So what we can wind up doing is going and taking a look at that sine of u plus v. That's one of our identities. Okay, so sine of u, cosine of v plus cosine of u, sine of v. And you should have these on your note card from the lessons prior. So what we can do is we can now use this identity and plug in our information. Okay, this becomes sine of sine inverse of a half times cosine of cosine inverse of 5/13 plus cosine of sine inverse of a half, times sine of cosine inverse of 5/13. Okay. Okay, so sine of sine inverse of a half is just going to be a half. Again, it's in that interval of our restricted range. Okay. Cosine of cosine inverse of 5/13. Again, 5/13 is in my restricted domain, so that simply becomes 5/13 plus cosine of sine inverse of a half we actually have to look at that. So let's take that step and hold it for just a second. Okay, we've got sine, and we're going to do the same thing for the next one because we don't have our nice simple rule that we can use. Okay, so this becomes 5 over 26 plus. So now we need to figure out cosine of sine of a half, sine inverse of a half. Okay, so sine inverse of a half, we need to know when does sine equal a half. And we know sine is equal to a half at 30 degrees. Okay, or pi over 6 is another way we can say it. Okay, so this becomes, oops, sorry about that, cosine of pi over 6. And then sine of cosine, when does cosine equal 5/13? Now that you actually do have to go and figure out, okay? So what we're going to do is we can go ahead and build this triangle. We can build a reference triangle in quadrant 1, okay? So let's make it so it looks like it's in quadrant 1. So adjacent and hypotenuse. Because remember, again, this is cosine theta equals 5/13. It's just another way to write it, okay? We need to find that missing side, which is going to be done using Pythagorean theorem. I'm going to find it to be 12. So if we want cosine theta, we're saying cosine theta, and here's my theta, cosine theta is 5/13, and I want to find sine of theta. We can go right from this reference triangle and know that sine is opposite over hypotenuse. So that's going to become, that whole piece is going to become 12/13. So I can actually take away that sine and write it as a whole as 12/13. Okay, so two more steps to go. We still have our 5/26. We're going to carry that on down. And we need to determine what cosine at pi over 6 is. Now again, pi over 6 is equivalent to 30 degrees, so cosine at 30, you guys should know, is square root of 3 over 2, and that's your exact value, times 12 over 13. Just keep going here. We've got 12 square roots of 3 over 26. And then finally, to finish it up, we get 5 plus 12 radical 3 over 26. Okay, so again, you're using your sum identity to figure out what this is. Okay, all right, so please make sure you've jotted down any questions that you had during the video. Come to prepared to class tomorrow. Remember, your quick check is going to be on lesson 6.4a, so be ready for that. All right, thank you guys.